Okay, so let's start with D here, okay? So what we need, okay, so here, first of all, the parentheses, I don't know if you have them.
We do.
Okay. So let's see, what would you pick as the U in this case?
X cubed plus
X cubed plus
x.
x, because that is the inside function. Is 3x squared plus 1 an inside function?
No.
It's not, okay?
Why?
Huh?
What's the reason for that?
I just thought they
Because, right, so this, look, this is just 3x squared plus 1. This is a binomial. 3x squared plus 1 is a binomial. This is also a binomial, but it's quantity squared, okay? So this one has been inserted into a squaring function, okay? So we take the inside x cubed plus x. And then du, see that? Okay, so that's what I was going to say. Du is equal to 3x squared plus 1 dx. You see how beautifully it works out? So okay, so suppose you picked the wrong one. Suppose you pick 3x squared plus 1. You find du, and then you see that there is no way you could match anything else. So you say, okay, I must have picked the wrong u. Okay? So you go back, no big deal. And then eventually you learn and you, it'll be reflex. So now, take a look. This, let's reorder this, rearrange it. So let me write this first. And then, I'm just rearranging it. 3x squared plus 1 dx. So now this is going to be the integral of u squared, and all the blue stuff is du. So now after this it's easy. U cubed over 3 plus c. So x cubed plus x cubed over 3 plus c.
And there's no need to distribute.
No.
Just leave it.
Leave it. Distributing it, no. We don't do that. Okay.
Will this be what you guys are finishing over in the cell?
Yes.
Chapter?
Yes.
I have one.
Yes.
How do you get rid of the du?
The
When
du.
you take the final integral.
Oh, well, remember in the last chapter, so if I have like x dx, right? That whole thing, when you take the antiderivative, it's x squared over 2 plus c. That's it. So, right? So this and this together, like the integral sign and the dx are a package deal. Together, they tell you to integrate. So once you integrate, the integral sign and the dx disappear together. Okay?
What about du?
Same thing. So if it was u du, right? It would be u squared over 2 plus c. Again, this and the du are a package deal. They come together and they disappear together. You can't have one without the other. You can't make one go away without the other. Yes, Julian?
Wait, the answer is just an integral of u plus c, right?
The answer to this problem D is this.
Wait, isn't that just an integral of...
Right. That's what I'm saying.
So why do we need to... Is that the case in every single question?
More or less, there will be some compensating for a function, like for a coefficient. Like sometimes you will have to multiply by a constant, like multiply by 2 or multiply by a negative.
But this isn't like one of those things like when you taught us how to do a derivative and then you taught us the trick afterwards, is it?
No.
Like you remember how like you taught us how to like do a derivative and then you taught us the trick.
Right.
We no longer need to do all those steps.
Correct.
This isn't one of those.
No. Okay. Okay, so let's move on. Okay, so let's do this trig one, okay? I know you had one I know you had a trig one on the homework, which you could have done with normal substitution and it would have worked out. So here, we did one here as well, right? Okay, and we, like D here, we did with use substitution, and it worked just fine. Now take a look at this one. Okay, here you have to use substitution, but you also have to put in a trigonometric identity to evaluate it. Okay, so what do I mean by that? Cosine cubed x, what would you pick as your u? Okay, so let's say you did cosine of x, right?
Yeah.
If you did u is equal to cosine of x, then du would be negative sine of x dx, but there is not a negative sine x dx in here to make this go away. So cosine cubed x, we can't do it using this. So then what do we have to do? Well, here it is. We can, okay, so cosine cubed x, it's 3 cosines multiplied by each other, right? Well, let's write it like that. Let's write cosine of x times cosine squared x dx. Can we do that?
Yeah.
Okay, now, this is equal to integral cosine of x times, now, in trig, there is an identity. It says cosine squared x is equal to 1 minus sine squared x. You guys remember that from trig? That comes from the fact that sine squared x plus cosine squared x equals 1. So for this cosine squared x, I'm going to put in 1 minus sine squared x dx. Okay? So now, what are we going to take as our u? Well,
Oh, wait.
Wouldn't it be 2x?
Negative sine squared x.
1 minus sine.
we're just going to do sine squared x.
What? Like, how do you know?
We're just going to do sine of x. I'm sorry. So now d, okay, let me do this and then I'll go back and explain it. So du is going to be cosine x dx. Okay? So now what? We're going to plug it back in here. So look, cosine x dx together, that's du, is that right? And then 1 minus sine squared x, that's 1 minus u squared. Let me put it in the blue. 1 minus u squared. And then cosine x dx is du. So now let's integrate this. What's the integral of 1? The integral, right, or u in this case, minus u cubed over 3 plus c. So this is sine of x minus sine of x cubed, or sine cubed of x over 3 plus c. If we want to use this for definite integrals, we can change the variables for definite integrals. So take a look at how we do this. So this is the formula. This is what we had before, right? So f of u of x times u prime of x dx, right? The original integral goes from a to b, right? When you change to u, what we also do is we change the boundaries from a to b to u of a and u of b. All right, so we also plug those in there. Let's do one here. We're going to integrate from u of a to u of b. So let me show you what I mean. Okay, this one, let's just see. What are we going to pick as our u? X squared minus 4.
Wait, why isn't it just x?
If you do just x, then du would be 1, right? And then you would still have like u over u squared minus 4. Like nothing will have changed. Okay?
Your result should be the derivative of it? Or?
Yeah, so now du is going to be 2x, right? dx. Okay, so now take a look at what we have here. What I have here is underneath I have a u, right? But look at what the leftovers are. I have an x dx, right? But so how can I change this to an x dx? Divide by 2. So half du is equal to x dx. So here I'm going to put half du. Okay? Okay, now I'm going to change these. You see how originally when we were dealing with x's, these went from 0 to 1? But now I change to u. So what I do is this. I take each of these bounds and I plug them into the x for u. So let's just do the 0 first.
What happened to x though? Isn't it negative 4?
X dx got substituted for du, half du. So now look, I'm going to take this 0 and plug it in here. So u of 0 is going to be 0 minus 4, negative 4. So here that changes to negative 4. Now I'm going to do the same thing for the 1. Plug it in there. U of 1 is equal to 1 minus 4, negative 3. So I'm going to go to negative 3. Now when I integrate, I don't have to change back to the x's. I could just plug these in there. All right? So let's just integrate this. Do you mind if I take that 1 over 2 outside? It's bothering me over there. So negative 4 to 3. And then this is 1 over u du. Huh? Oh, thank you. So then this is going to be 1 over 2. What's the integral of 1 over u? ln of u. And it's going to go from negative 4 to 3. I don't even have to plug the u equals x squared minus 4 back in there. Now it's just ingrained. So now this is 1 over 2. Okay. ln of what? Right. Well, the negative 3 goes in there, but it's an absolute value, so it's just ln of 3 minus ln of 4. So this is 1 over 2. Okay, remember your algebra 2. It's going to be ln of 3 over 4.
So when I was taking the test in here, the teacher was helping her students with that.
Oh. Yep. This is what we do in algebra 2. Okay, so let's remember our properties from algebra 2. We've sort of gone over this at the beginning of the year, but it's one that we always forget the first. Yeah.
You also have to put, when you have like ln, you always put the u and also the 2 bars.
You do, because when negative 3 goes in there, you can't have ln of negative 3, right? It has to be a positive value. Yeah. Okay, so take a look. Here is some algebra 2 for you. If you have ln of A plus ln of B, right? If you want to condense it, you write 1 ln A. Because there is a plus here, you multiply times B. If you have ln of A minus ln of B, it's ln of A over B. Now, if you have ln of A plus ln of B minus ln of C, what then? ln of A, B over C. Fantastic. Okay? So this is it. Okay? All right. So what about this next one?
Is it just secant?
Well, how are tangent and secant squared related to each other?
Sec squared.
Derivative of secant squared is tangent x secant squared x, and the derivative of tangent is secant squared.
Oh my god, the derivative of tangent is secant squared x dx.
Oh my god.
So, what if u is equal to tangent x?
I just don't understand how you know that. Like,
Then du, okay, I'll tell you. Hang on, let me do this one.
is there like a trick I'm missing, you know?
Okay, listen. du is equal to secant squared x dx. So take a look at what happens here. This is u, and this is just du, right? So suppose now you didn't know that. Suppose you chose, I don't know, u to be secant squared x. right? Then what would du be? 2 secant x times secant x tangent x, and there is no way you could plug those back in there and make it make sense, right? So
You know you're wrong.
you know
You
you're
start the problem, and then you have to go
right.
choose the other one.
So then you're like, oh my gosh, I picked the wrong one. When you get to a point where you look at it and you go, oh look, secant squared is the derivative of tangent, then immediately you know that tangent should be the u. Okay? Now, so this is going to be u du. And now let's change our bounds. So for 0, u of 0 is tangent of 0, which is 0. And sometimes that'll happen. It'll stay the same. It's fine. And then u of 1, u of pi over 3.
It's gonna be root 3 over 3.
Just root 3. Tangent of pi over 3 is root 3. Okay? So now, u squared over 2 is what we get from here. No plus c anymore. So we're going to go from 0 to root 3. No plus. Because it's a definite integral. We no longer. So now this is root 3 squared over 2 minus 0 over 2. And that's 3 over 2. And that's all. Okay? Okay.